Gauss's law for magnetism. Electrostatic वास्ते law किसी. Gauss's law for electrostatic was what? Yes, let us revise. If there is a charge Q, lines come out of the electric charge. The law was E. E represents what? Number of lines coming per unit area. ds is a small area. So E represents what? Number of lines per unit area into ds. Say 10 lines per centimeter square into 2 centimeter. So total number of lines coming from this area is 20. Total, all the lines coming out, integration. Total lines coming out of closed, like a football, coconut, tennis ball, closed surface. Total lines coming out of closed surface is equal to Q by epsilon naught. That was Gauss's law for electrostatics. 1 minute to write Gauss's law for electrostatics. Total lines coming out of a closed surface area is equal to Q by epsilon naught. Opportunity to revise chapter number 1. We will revise. 1 minute to write Gauss's law. Now, Gauss's law for magnetism is what? Equivalent to Gauss's law in electrostatics, you have Gauss's law for magnetism. You place a magnet, surrounding the magnet, think of a Gaussian surface, hypothetical surface. The law is lines will move out of north. Again, think of small area. B represents what? B represents number of lines, magnetic lines per unit area. ds, small area. ds or dA, whatever you call this. B into ds represents what? Small number of lines coming out of ds. So BDS represents what? BDS integration represents what? Total lines coming. But if you think of the total enclosed surface area, then mathematically you will have to write this simple. When this is area closed, means closed surface. If this is length, this is closed, that means closed loop, like a wire. You start from one end, reach to the other, then it is closed loop. Here, it is area. Closed area means closed surface area, like a football or a tennis ball, is equal to, yes, below 0, because whatever is the number of lines leaving, same lines will enter from other side. If the flux or lines leaving are taken as plus, then it is 1, 2, 3. 3 lines are leaving the surface. 1, 2, 3. Three lines are entering the surface. Net magnetic flux linking the surface is 0. This is Gauss's law for magnetism. Time with you is 2 minutes to write. So it has to be vector form. B and ds both are vector quantities. Here also you can mark as vectors. Three special cases, or you can say examples of the same are, example number 1 is what? Magnet is totally inside. One case, three possibilities are there. So in terms of example, I will say case, discussion. Case 1. A magnet is totally enclosed. There is a magnet. It is totally enclosed inside the Gaussian surface. In this case, number of lines leaving is equal to number of lines entering. So for this case, it is true. Case number 2. There is a magnet. Yes, case number 2 is what? Outside. There is a magnet, and this magnet is outside Gaussian surface. So you draw a Gaussian surface outside. North, south, wait कर लो कोई गल नहीं. North lines yes, number of lines entering the surface 1, leaving the surface 1. You would take leaving the surface to be minus, entering to be plus, then minus 1 and plus 1 comes out to what? 0. So again this is true. BDS. Case number 2 is what? Magnet is outside this Gaussian surface. Time with you is 2 minutes. 2 minutes to draw the diagram. Case number 3, partially in. Case number 3, there is a magnet, north, south, and you draw a surface such that Gaussian surface such that part of the magnet is in and part of the magnet is out. For this case, again this is line leaving the surface. Suppose leaving the surface I mark as +1. This is a line entering the surface. It is -1. Then +1 and -1 number of lines connected with the surface comes out to what? 0. If it is true, BDS is equal to 0 is true for a partially enclosed magnet. Time with you is 1 minute. Draw it. Question number 8. Question number 8 deals with what? Earth's magnetic field. A part. Mark Earth's magnetic field. That means Earth's magnetic field and cause. Causes like that because it is not known. All of you agree that there is a magnetic field of Earth. You would take a magnetic needle and you place it, it orients itself in a particular direction. It orients it in particular direction. It is pointing towards north, slightly bent, but I can say it is this one. So there is a magnetic field due to Earth. First part. And the Earth behaves. Earth rotates about this axis of rotation. This point is termed as geographic north. This is geographic south. Earth behaves as if there is a magnet inside. And there is a magnetic field because of this magnet. This axis, magnetic axis, this is geographic axis, this is magnetic axis, there is an angle between the two. This angle you will find different value in different books. 11 degree, 12 degree, 13 degree, 14 degree, 15 degree. Say of this order. Reason is, why a different answer in different books? Reason is, this value keeps on changing, and after thousands of years, this angle theta, this Earth will behave as if this magnet is rotated by 180 degree. This value keeps on changing. Angle change with time. At present, you can say theta is approximately equal to 14 degree. If a book writes 15 acceptable, 16 acceptable, 12 acceptable, here it is 14 degree. In the notes given value is 14 degree. Nothing to worry about because it keeps on changing. So, someone will average over 10,000 a year, someone will average over 20,000 a year, that value will come out to be different. Then comes the cause. Causes. Theory 1. Some people say the cause source is inside. First, iron charges equivalent to current loop inside earth means what? Theory 1 is inside earth there is molten metal. Charges. When those charges rotate, when the earth rotates, those charges also rotate. So, it is equivalent to what? Current. Whenever there is a current carrying loop, there is a magnetism M. So, this cause is inside the earth. This is 1. Theory 2. Some people say no, there is earth and surrounding the earth there is atmosphere. Agreed? And in atmosphere there are ions, charges. When the earth rotates, that atmosphere also rotates. That causes current I in a ring. That causes magnetism M. Still we are not clear what is the exact cause, because if you explain the cause, you will have to explain why it changes with the time. Then you will have to explain the rate of a change of field with the time also. That is why there are two possibilities. Either the cause can be inside earth or outside earth. Time with you is 4 minutes to write. 3 marks question, board question. B part. Magnetic elements of earth. Three. One is magnetic declination. In B part, you have 3 parts. Magnetic declination. Magnetic declination is defined at a place as the angle. It is angle between two planes. One, magnetic meridian, angle between magnetic meridian and geographic meridian. Meridian means plane. What are these two planes then? One, earth is a sphere like an apple. If you have an apple, take a knife and if you cut it symmetrically like this, it will cut the earth in 2 equal parts. Agreed? If this knife is parallel to this axis of a rotation, then this knife, this plane is termed as geographic meridian. Again repeat. Earth, you have to cut earth in two parts, not like this. You have to cut it in two parts such that this knife coincides with this axis of a rotation. Then this is geographic meridian, this is one. And we can mark it like this. Two planes I want to mark. Say there is one plane, geographic meridian. This diagram is different from this one. And what is the magnetic meridian? Anyone? There is, yes, there is equivalent axis like this. So if you take another plane and this knife also cuts the earth in two parts, then this plane can be termed as magnetic meridian. Angle between the two, which is again likely to lie between 10 to 20 degree, will vary from place to place because it is equivalent to a magnet. It is not exactly a thin line magnet placed inside. It is equivalent to a magnet. So, if you mark another plane, this plane, blue color plane, is magnetic meridian. It is the angle between magnetic meridian, which is this blue color, and geographic meridian, red color. The angle between the two is termed as declination. Here this is marked as angle theta. Time with you is 3 minutes to write magnetic declination. 3 minutes to write. Point number 2 is what? Yes? What is magnetic dip? Yes? As per definition, magnetic dip is what? Magnetic dip at a place is defined as the angle which the direction of a total strength of Earth's magnetic field makes with the horizontal line in magnetic field. Let us first try to understand what it means. Because in case you don't understand, you won't be able to answer objective questions. This is the plane. In this room, this is the plane magnetic meridian. So take a needle. If you place this needle and allow its vertical motion also, it will incline it like this. It is not horizontal. Why? Because if you consider this to be a magnet, the line comes out of the surface and at different positions. Here it is perpendicular to the surface, our surface. Here at this point it is parallel to the surface. So at different positions, this line makes different angles. So say at this place in Bhatinda or in Delhi, this makes some angle with the horizontal. So it is not horizontal, it may be horizontal at some place, but it makes some angle with the horizontal. Say 30 degree. If it makes 30 degree with the horizontal, 30 degree with the horizontal, then dip at this place is 30 degree. So magnetic dip at a place is defined as angle which the direction of total strength. So first I will mark magnetic meridian. This is magnetic meridian, MM. In this magnetic meridian, if you place a needle, the magnetic field is B. I will change the nomenclature as given in the notes, and it makes angle delta. Say 30 degree. Then this delta is the angle which the field makes with the horizontal. So magnetic dip is delta. Repeat. Magnetic dip at a place is defined as the angle which the direction of a total strength. This is B is the total strength, which the direction of total strength makes with the what? With the horizontal. If I am to draw it in this diagram, then angle with the horizontal line. This is the plane. It makes angle delta. Time with you is 2 minutes to write. 1 mark question, what is magnetic dip? You need to draw this much only. Right, it is magnetic meridian, angle which B makes with horizontal. Third is what? Point number 1, 2, 3. Horizontal component. If you know B, if you know angle delta, can you find out BH? In the notes it is written as H and B. Can you find out H? H by B is equal to what? Cos delta. So H is equal to what? B cos delta is horizontal component of first field. V by B is equal to sine delta. V is equal to B sine delta is a vertical component of a Earth's field. We need it in chapter number 4 also, horizontal component and vertical. Repeat. The conclusion of the article is, in this room, magnetic field is inclined at some angle with the horizontal, say 30 degree. You can find its horizontal component and a vertical component. That's all. Time with you is 2 minutes to write horizontal component. Discussion for the same. As per the notes, we will change the order. Point number 1. Dip at poles. Yes, this is the north pole, Suppose this is the south pole. Near the poles, the field will come out to be what? Near the pole, yes. If you make a room at the pole, this is the floor, this is the roof, this line makes what angle? 90 degree. Here also, if you make a room at the pole, this is the floor, floor can करना है? The surface touching the surface of earth. That is why this is the floor in this case and this is the roof. So floor, what this angle is equal to? 90 degree. So what is the value of dip at poles? Yes, objective question, 90 degree. Correct? 2. That is point number 3. At a place on the equator, that is point number 2, dip at equator. If you make a room here, this is the floor, this line is parallel to the floor. So this line makes what angle with the floor? 0. Dip delta at equator is equal to 0 degree. Time with you is 3 minutes. 3 minutes to write. Correction is required in notes. It is there. Third point, poles we have changed to equator. So 2 objective questions from discussion. Value of dip at poles and at equator. Notes बंद कर दो. This is the only part from the chapter where it is difficult to draw a diagram. 1, 2, difficult to answer the objective questions. So we'll try to explain it to the best possible extent. I will redraw this diagram. This blue color plane is what? Magnetic meridian. I will complete it. Say this one. I will redraw this. This is MM, magnetic meridian. The red color is what? Geographic meridian. The magnetic field is B. It makes what angle with the horizontal? Delta. What is the angle between the two planes? Theta. We have taken all the information given here. So it's the same diagram, but size we have increased. I need to mark it the same color code. It is just like this arrangement. two planes inclined to each other at certain angle. It is this case. And this is the common axis, this one. If you mark this as a common axis, this is a common axis. Am I right? This one. In this blue color plane, can we write H and V? Yes. In this blue color plane, this is the value of H. So this is the value of H. And the vertical component here, this is the value of V. H is equal to what? That means that H is equal to B cos delta, and V is equal to what? V sin delta. This is we are talking about the dip in blue color. That is termed as actual dip, because dip is defined only for magnetic meridian. Apparent dip, that means in the other one, that is for this red color, the common component, this component, vertical component will remain same. Agreed or not? Vertical because the two planes have something common, axis of rotation. That is why vertical component of the two will remain same. That is why V dash is equal to V. But horizontal component in this plane, red color plane, is H cos theta. If there is a value, say this value is given 10. What is the component of this plane in this plane? Here, 10 cos theta. Vector along any plane, A, angle between the two planes is theta, then the vector along that plane is A cos theta. H dash is equal to what? H cos theta. In this case, dip is what? Delta. In this case, dip is what? Tangent delta dash is equal to what? What is tangent delta equal to? Second by 1, V by H. Tangent delta dash is equal to what? Tangent delta dash is equal to V dash over H dash. V dash is equal to what? V. H dash is equal to what? H cos theta. So V by H is tangent delta over cos theta. Apparent dip, tan of apparent dip. Here I can write this to be as apparent dip case. This is the case for actual dip. Tangent of apparent dip is equal to tangent of actual divided by cos of theta. What is theta equal to? Angle between the two. In case angle between the two is 0, cos 0 is 1, then it is the same story. So you have 3-4 questions which deal with angle between magnetic meridian, and it is here I have written as geographic meridian. It is true for any plane making angle theta. It need not be geographic meridian. So in competition you get questions which deal with any plane. Time with you is 3 minutes to note. 3 minutes to note.